Capmix. To produce energy, one can use many different sources. The favored choice of our industrialized world has been fossil fuels like coal, oil, or natural gas. But there are two major disadvantages to these sources. The first is that fossil fuels are becoming more and more scarce. The harder it is to find these fuels, the more expensive it is to use them. The second disadvantage is that the use of fossil fuels damages our environment and contributes heavily to the emission of greenhouse gases. The answer to these problems is renewable energy. There are abundant sources of energy that can be harvested without degrading our world. Windmills capture wind power, and solar cells turn sunlight into electricity. Though green energy is increasingly popular, the approach is still insufficient to satisfy our ever-growing needs. That is why we at Capmix are developing a new way to extract energy from water. We call it Salinity Gradient Energy. Salinity Gradient Energy is the power one can extract when liquids with different salt concentrations mix in a controlled way. In practice, this means that energy can be harvested from the mixing of river and seawater. But how can energy be made available from simple mixing? To illustrate this, imagine that you put a drop of ink into a glass of clear water. Over time, the ink will spread throughout the glass and the water will become uniformly blue in color. This is because there is energy available to drive the movement of the ink particles. With Capmix, we do the same, using salt water instead of ink. In nature, this process happens every second of every day, as fresh and salt water mix in river deltas around the world. This energy can be extracted if the mixing is controlled. It is estimated that the amount of power available through the joining of rivers and oceans could meet our current electricity needs the world over. Capmix is a European collaborative project developing a new technology to extract energy from this process called capacitive mixing, or Capmix for short. Capmix is a new concept in which capacitive electrodes are used to extract energy from the change in salt concentration between sea and fresh water. This is done by charging a set of two capacitive electrodes in seawater and then discharging them in fresh water. You can look at it this way. When salt water flows through the Capmix cell, sponge-like electrodes will capture the charged species from the dissolved salts. When fresh water flows in afterwards, the electrodes will let go of the charges, creating an electrical current. Within the Capmix project, two different approaches are being investigated to separate the charges present in seawater. One approach uses external energy to drive opposite charges into the electrodes. During the discharge step, more energy is recovered than was invested. The other approach uses charge selective membranes to control which charges can enter the electrodes. The premise is fairly simple and can be done on a small scale in the laboratory. But the technology for realizing a full-scale Capmix power plant is still under development. Together, Capmix researchers are working hard to develop this technology and advance a new way to generate sustainable and renewable energy. Capmix is a consortium of 6 partners from 5 European countries that combine their expertise to make the project a success. With the help of these partners, Capmix aims at bringing capacitive mixing technology forward and demonstrating its competitive potential in the global energy marketplace. Our goal is to produce an upscaled prototype working under real-life conditions within the 4-year timeframe of the project. We hope that you are as excited as we are in seeing this endeavor become reality. For more information about the current state of Capmix and for in-depth details on the technology behind the concept, please visit our website at www.capmix.eu.